Cool. Now we're recording. So yeah, just an FYI, I will be posting these slides on Canvas as soon as this review is over, so be on the lookout for that. And so there will be two review sessions. This is the first of two. The following will be led by Edna, and she will most likely go over the sample questions. So if we have time, we can go over sample questions. If we don't have time, then we'll probably just like go over these concepts and one or two sample questions, the ones that people have most questions about. Yeah. Any questions about anything else, format or something like that of the test? Is everyone good? It will be open booked the way that test one was. You cannot use Jupyter Notebook or any type of Python environment, or like the way that so you basically can't use like Jupyter Notebook, you can't use Spider, so on and so forth, but it is like open book, so you can use your book and your notes that are not in Jupyter Notebook format. So if all your notes are in Jupyter Notebook format, make sure you make them HTMLs or PDFs so you can access them. Any questions?
Wait, can you say that last thing really quickly again? What files?
Yeah, so if your notes, I know some people take notes in Jupyter Notebook. If you have been taking notes in Jupyter Notebook, make sure you convert them to HTML, because we do not want you all opening any type of Jupyter Notebook or like anything like that. Other questions? Cool, so let's get started. So today we are, let me just make sure this is recording, we're fine. Okay, so today we're going to be going over dictionaries, sets, functions versus methods, NumPy, pandas, parameters, and then machine learning, which Professor Cannon just went over in the last lecture. And these are all things you should expect to be in the exam. For the most part, it will be focusing on the stuff that you learned this half of the course, but the stuff that you learned in the previous half is also very important because everything builds on top of each other. So yeah. So are there any questions so far about topics or anything?
Is there like a percentage, like the things we covered after the first test are like gonna be 80%, the other 20%? Is it just
I'm not sure, honestly. I do think most of it will, like more than 50% will be this, for a fact. I'd also really look at the sample questions because, as you guys probably noticed in test one, there were very similar things. So yeah, just something to keep in mind.
only got 10?
Let me just check the chat. So question, will I be posting the slides? Yes. They will be posted under files. Cool. Under files in Canvas. So now let's go over dictionaries. So recall, basically dictionaries are sort of pairs of a key and a value. And one of the requirements that dictionaries have is that the key must be unique. I also added that dictionaries are mutable, right? There were a couple of questions about list being mutable, as well as I believe strings in the previous test. So dictionaries are mutable, which means that we can change its value after it is created. So this means that, like, unlike things that are immutable, usually with immutable things, if we want to change something, we have to make a copy of it and change the original and make a new copy and overwrite that. So yeah, dictionaries are mutable. And so here I put a little example. So we have our empty dictionary called grocery list. And then in there, I'm adding the key veggies. So this is how you add content to your empty dictionary. And then I'm saying veggies is equal to a list of carrots, lettuce, potatoes. And then after that, I'm making a new key called fruits. And I'm saying fruits is equal to the string strawberries. And then at the very end, I'm saying x is equal to 24. So if you notice, keys can point to all types of things. I think you all should focus just on lists, strings, integers for the class. But yeah, as you can see here at the very end, I didn't I didn't put what my ending dictionary would look like, but my ending dictionary would look like veggies pointing to the list, carrots, lettuce, potatoes, fruits pointing to the string strawberries, and eggs pointing to the number 24. And so when I try to do groceries.keys, this will give me all the keys inside of my grocery list dictionary. And then if I try to do grocery list.values, it will give me all the values of it. But in here, notice how these values keep their types, right? So if you'll see here, the first one is still a list. The first one is still strawberries as a string. And then the last one is still just a number. Are there any questions with dictionaries?
Can you make a dictionary of dictionaries?
You can make a dictionary of dictionaries. So we did this with the Mickey Mouse problem lab. So if you guys remember, we basically did I believe it was like a names dictionary and then an emails dictionary. So yes, you can make a dictionary of dictionaries. I think when it's mostly helpful is like when you're thinking of a phone book. So I could make, for example, a dictionary of cities or like the area codes. And then from there, it could point to different phone numbers in different, so like basically I could make like a dictionary of counties, and then those counties are pointing to cities. And then inside of there is all the phone numbers in cities. So that's just like an example of like a dictionary of dictionaries. I'm hoping it won't be that complicated for you all, but just, yes, that's a good question.
And when you print the whole dictionary, the values keep their same, like they're still integer string.
Yes,
right?
exactly, yeah. So that was my bad that I didn't print it down here. But yeah, basically like veggies would point, it would be like veggies, the string veggies is pointing to the list. And then fruits is pointing to that string. And then eggs is pointing to that number. Mm-hmm. Yeah, the same thing goes when you return something. So when you print it, it will keep its everything. And when you return it, I guess like the small, yeah, for our purposes, everything stays the same. I don't want to. Are there?
I was raising my hand. I didn't know if you saw it.
Oh, sorry. No, I didn't.
So I'm just confused. How exactly would grocery list.keys print out? What's the dict_keys? And then wouldn't it just print out like veggies, fruits, and eggs?
No. So here it printed out veggies, fruits, and eggs because we only wanted the keys.
Yeah, so wouldn't it just print veggies, fruits, and eggs without the dict_keys in front of it?
No, so it would actually print out veggies, the list of carrots, lettuce, potatoes. I can also run it if you all want to see it. Give me 2 seconds to, so this is what it would look like. Tablet. I have a Jupyter notebook going. This is from lecture 20, which I wasn't gonna go over lecture 20, but I was gonna.
I don't think we can see it.
Yeah, let me write it up.
Is lecture 20 the one that's not going to be on the test?
No, lecture 20 will be on the test. I believe it was lecture 19 that won't be. So in here, just ignore everything in the bottom. So in here, I'm gonna make my grocery list, and I'm putting an empty dictionary, and then from there, I'm saying grocery list veggies is equal to, I'm gonna make a slightly shorter list, tomato, lettuce. And then I'm gonna do the same thing for fruits, but instead of having a list, I'm just gonna have strawberries. And then after that, I'm gonna have eggs with a, with a number. So X, 24. And so when I print my grocery list, this is what it should look like. So as you can see here, it just has veggies, and then to the list, fruits to the strawberries, and eggs to the number that we have, which is 24.
Yeah, that's what I meant. I meant that when you said print out grocery list dot keys, and then the black next to it says dict underscore keys and then parentheses.
Oh yeah, so, but I thought you were saying that it would only print out the keys. So it wouldn't just print out the keys. I think I misunderstood. That's my bad.
When you print grocery list dot keys, it doesn't print out the keys.
Oh, I see. So like this? Yeah, so this one would just print out the keys, but it will, so
Oh,
it
so
says,
it will print that out.
yeah, but the thing is that when you check the type of what this is, oops, I'm missing one. This is like an iterable thing though. So for example, if I did for I in range length of, actually no, I'm not going to do for range, for I in grocery dot keys, this is something that is iterable. So it's not exactly a list, but you can iterate through it, which is what we've done in previous homeworks. So if I print here, you'll see that you get veggies, fruits, eggs. So it's the fact that it prints saying like dict keys is not that important, because at the end of the day, for the most part, it sort of works like a list, with the exception that I believe you cannot index this. So you try to index it. Actually, let's try it out, because I believe you can't, but just in case. Yeah, so with the exception of like this is not indexable, it sort of works. So this would be helpful in scenarios of like, I want to go through all my keys of my dictionary and I want to access every single value. So this is what that would be helpful for. But unlike a list, it's like its own type of thing. So we haven't really gone over that yet, which is why I don't want to confuse you all too much. But the idea is that grocery list dot keys returns its own type, which means that it has its own things. And that's all we have to know for now. So yeah, it will return it with like that thing of like saying dict keys, because it wants to tell you, hey, this is like not a list, it's like another type. So yeah.
And if we want to print out only the values of fruits, you do grocery list parentheses fruits.
Exactly, yeah. So we would do grocery list, fruits, and then this is going to give us back our value at that specific key, which will be in this case strawberries. Mm-hmm.
Thank you.
Mm-hmm. Any other questions? Let me see. Let me go back to here. Any other questions? Actually, let me check the chat really quick. So it says, why is lecture 19 not on the test? Yes, because it's context specific. So any lecture that was context specific, we will not be going over, because everyone's going to have the same test. Let's see. What lecture does test 2 content begin? I don't remember the exact number. I believe it is like 17.
I think it's 13.
13?
Oh, I thought it was 13.
Oh, you might. I think. Oh, yeah. Half of it. Yeah, that's half. Yeah, it's 13. It should be around 13. And then it should go 13 forward with like, just have in mind that we had context specific lectures. So those that were like on Thursdays that there are no notes for are because they were context specific lectures. So for example, I think like 17 is missing, 15 is also missing, so on. He said it's mostly things since test 1. Yeah, but since all computer science builds off each other, it's technically cumulative. Yeah, exactly. So you should know how to deal with strings. So that's something that I would definitely cover. So sort of how to handle, like if I index from 2 to nothing, so like 2 : empty, what does that give me if I have like the specific string. I'd also go over like how to reverse the string. So string manipulation, I think, is always super helpful. And that's something that I would definitely go over from test 1 that I think will be relevant for this test. What other stuff? Functions are very helpful. So we're going to be going over like the general idea of functions, but sort of the specifics of like how do you define a function and what do you do with those parameters. I mean, I think if you guys get parameters, functions should come naturally. But I think those are the 2 things that I would say are very, very important. Any other questions from
Can
what
you search? Can you get the key by typing in strawberries? How?
you cannot? So basically, Python only has knowledge of the keys. And so if you want to find strawberries, you have to go through every single key and find which one is equal to strawberries, essentially. So I guess like another, yeah, you would have to go through every single one of them, which, yeah, is not that great. But I think the reason why dictionaries, like if you only cared about the values, then you would just basically make a list, right? Instead, yeah, it's just the way that dictionaries work. So you can look for you need a key to access the value, and so that's just always going to be a thing. Are there any other questions or follow-ups on that? Questions. Also, if you raise your hand, I probably cannot see you. Cool, so we're gonna keep going. So I did like a couple other examples in here. Here was an example that I realized was not relevant to you all, so I put that, so just ignore that. But here I made a new dictionary, and these are just examples of like different things that are helpful with dictionaries. So this is all the same as what we've already gone over. Oh, here there's an example of how the dictionary would print. Forgot about that. But yeah, I think the most important part of this one is notice how you can convert a dictionary to a list, but it will only grab the keys. And it will only make the keys a list. Same thing with you can sort the keys of a dictionary. In this case, it's sorting them by like alphabetical order. And then you can also check if a certain key is inside of the dictionary, and that will return a true or false Boolean. Are there any other questions? Are there any questions with this? Cool.
Why isn't SAPE in TEL?
Oh, so actually the one that I didn't think of that. Okay, so the one that I deleted was deleting a key from the dictionary. So that's a good call out. Let me see if I can exit this presentation. So yeah, I just used del. So I don't think this is something that we went over in class, but you're right, this messes up everything. So what was in there was just saying like del, the dictionary, and then the key. And what that does is that deletes a basically like key pair from the dictionary. I believe we didn't go over this in class. Maybe we went over it briefly. I can almost with like 99% confidence say that this will not be on the test, which is why I tried deleting it. Because yeah, I don't think we ever went over it. This is like a sample that I took from a web development site, so yeah, but nice catch. I didn't even notice it when I deleted it, so good catch.
What does list tell? Like,
Yeah,
what does it do?
Remember that TEL is a dictionary. So what it does is that it converts the dictionary into the list. But more specifically, it converts the keys of the dictionary into a list. So if you notice, like not the whole dictionary is inside of this new list. It's just the keys that we had in here, which are like Jack.
So it doesn't store the values?
No, it doesn't. It just keeps the keys. So this is another way of, let's say that you want to iterate through every single key of your dictionary. This is another way of like getting those keys. That is not dot keys that we just went over.
In order to sort,
Sorry, is that valid?
No, I think it's someone else.
Oh. Yeah.
It's me. In order to sort the dictionary, you need to like turn it into a list first, right? You cannot sort the dictionary directly.
Yes, that's a really good point. So in order, actually, let's try it out. Yeah, I believe you're right, but let's just make sure.
Because here it's sorted only the keys. If we're gonna sort the dictionary, I'm not sure if it's gonna sort the keys or the values. So that's why I asked.
So let's try it out. Yeah. So if I do, I think you're right. I don't think you can sort a dictionary. You're just sorting the list that you just made. So if I do sorted grocery list, let's find out. Oh no, that does work. So if grocery list is a dictionary and you run, I think sort doesn't work. So if you try to do grocery list dot sort, that is only a list specific. Yeah. So you can do sorted on dictionaries.
Thanks.
Good question.
But then it only sorts the keys?
Oh yeah, it only sorts the keys. So the thing with dictionaries is that basically they only have access to the keys. They don't really care about the values unless you use the keys to get to the value. With the exception of dot values, right? Dot values returns all the values in the dictionary, but then you lose the connection between, like, not that you lose it, but like then you're not seeing what the key is, so you're just seeing the value. So dot values is like kind of helpful in cases where, like, let's say I have everyone's name as my keys, and then, or assuming that everyone has a unique name, right? But let's assume that like there are not 50 Ilianas in the class, and which, I mean, I doubt there would be, but let's assume that, right? And so what I can do is I can do dot values and then get the scores or the averages of everyone in the class, and then get like the mean for that. So those are some of the cases where like that is helpful, where like you don't necessarily care who it belongs to, you just kind of want to know like a general idea of like what are the values looking like. So yeah, let me know if that answered your question.
So basically sorted just returns a list of sorted keys, but it doesn't do anything to the dictionary.
Yeah, so if I print the grocery list here, it is the same. So it's still veggies, fruits, eggs, and it's still unsorted. So I'll actually be going over this a bit more further down the line when I cover functions and methods. But sorted is a function. So sorted returns a new, basically, list of sorted keys of grocery list. And it doesn't actually change anything about grocery lists. But I'll be going over it a bit more. I'll be going over sorted a little bit more down the line. But are there any other questions? Because dictionaries are super, super important. I can 100% guarantee that there will be a dictionary question. Any questions? Cool. So let's move on to sets. So let me just go back to sharing this. So now we're going to go over sets. And so just to refresh, sets are a collection of things with no duplicates. And sets are mutable, which means that you can change its value after it is created without having to create a new thing and like overwrite that and go through that very annoying process. So in here, I've created an empty set, and you see that I have set parentheses. So then I have the question, why can't I do the bracket stuff? Just empty brackets. Can anyone tell me? So it's actually a trick question. You actually can. And so basically, another way to think about a set is a dictionary, which is like a very weird way to think about it, but hear me out. A set could also be sort of considered a dictionary of only keys. So we said that keys in a dictionary have to be unique. So it's the same idea with the sets. Are there any questions?
So a set is like a dictionary with no values?
Exactly. Yeah, it's basically a dictionary with just like basically just the keys in something. And so, for example, I have my set in the bottom there. And so I say that my set is equal to 3, 6, 6. And so in there, I clearly have repetition of the sixes. So when I check the length, what should the length of my set be?
2.
Yeah, it's going to be 2. And the reason why it's going to be 2 is because, yes, I declared it as 3, 6, 6, 6. But what's going to happen is that these 2 6s are going to disappear because I only want things that are non-repetitive. So if you put things that are repetitive into a set, it will just ignore you and be like, sorry, this is already in here. I'm not going to add it.
But where do you turn it into a set?
Oh, here. So I'm saying my set is equal to 3, 6, 6, 6. So if it has the brackets, that is a set. It just, I think for the most part, you probably have only seen this part of like I'm calling a set and then adding stuff to that. But this would also be a set.
And when you print my set, is it 3, 6?
Yeah, my set would be 3, 6. So I can run it for you all as well. So that print, let me just share my screen. Sorry, screen sharing is. So for example, let's look here. So in here I have L, and so I just created an empty list, or I just have my L here. And so when I print L, you'll see that, let me print this out. You'll see that L ends up just being 3 and 6. Now let's say that I have a 6 here and I have a 3 here, then that would give me the same thing. So just 3, 6. So yeah, sets are very helpful when we don't want repeats, and that's just something important to remember. Yeah, any questions about sets?
Can I just clarify that? So for a set is different from a dictionary. Like, how does it know that you're printing a set instead of a dictionary that has no value, like an empty value for the key 6? Does that make sense?
Oh, I see. So how does it know when something is, so if I print out the type of this and save it into L, this is going to give me class set. And the reason for that is because it doesn't have any values associated with it. If I all of a sudden do 6 is hello, this I think will actually break. Let's find out. Yeah, so this will break because I have something that has a value, and then now I have repeat keys. So it knows it's a set because none of them have values. If it gets, basically it like, so my guess, the way that like it processes behind the scenes is it assumes it's a dictionary, and if it goes through it and doesn't see any value associated to the things, then it's a set.
Got it.
And so another way we can do a set is by calling set like that. And then if I do type, so here, if we do type set, and then if I do, also my names are terrible, please ignore them. It's just for me being as quick as possible. So if I do that, you'll see that. So I'm gonna print out L, I'm gonna print out, actually I'm gonna print out W and H, and this will give you the type of each. So when I run this, you'll see that this is considered a set. This is considered a dictionary until told otherwise. So if I fill it up with only keys, now it's a set. Which is why I like the question of like, why can't I do brackets? So the reason why you possibly couldn't do brackets is because at the very beginning, it's going to be a dictionary. Does that make sense? Let me see if there are any questions in the chat. Why was 6366 printed as 36 if sets are unordered? So they are unordered, but I think sometimes environments, so like Jupyter, Spider, and stuff, do weird things. They're still unordered. I just think that the environment that we're in just prints them out like that. Yeah, I wouldn't look too much into it. I've also wondered this myself, but I'm like, this doesn't happen to me if I'm running it somewhere else. So I think it's like a Jupyter specific thing, or a Spider, more specific, like an Anaconda specific thing. But yeah, that's a good question. I think if you run it in Replit, it doesn't do that. I don't think I have a tab open, like a Replit thing open. Otherwise I would show you. But yeah.
Would you mind putting an H, like maybe just 2 keys with 2 values, and then
Yeah,
showing us
have
how
H.
when you delete it, it's a set?
Yeah, so I'm gonna do age is equal to, for now, an empty dictionary. So let's do age for, I think it's append. Let's see if this works. Actually, I'm not sure. Let's see, print age. Nope, I can't append to that. Let me, oh. So I guess the issue is that how would you append to a dictionary? How would you only append a key to a dictionary? Besides
I
writing
think I would
it.
use, sorry.
Oh yeah, what would you use?
Wouldn't you do H square brackets
But
and
then,
then name?
yeah, but then the issue is that you need to equal this to something. Or actually, let's see if this works. I think, I don't know why I put visit, but I think I was thinking hello. So let's see. Yeah, so the problem, I know why I wrote this now. So the problem is that in order for you to add a key without like basically explicitly writing it in, is that you can't just add a key without putting a value to it. So let's go back.
Yeah, so I initially just wanted to see how, when you have a dictionary with keys and values, what happens to the dictionary once you remove the keys. Like I just wanted to see how it, the values. I just wanted to see how it actually turns into a set.
Oh, you can do .add. I found it. Or I mean, according to the internet, you can do .add. So let's go back to new share. Sorry, you guys don't see new share, but I see new share. So I'm gonna go back to showing this. So if I do h.add visit and then print h. Oh, I guess it doesn't have an attribute add. Oh yeah, so it has to be a set. Okay, so basically like you have to make it a set first if you only want things to have that. Like it has to start off as a set. So I guess this, so okay, so kind of confusing, but if you want to have an empty set, it has to be just set. Because if you make this will be a dictionary. And it will remain a dictionary. The only exception to like we can use this dictionary notation, or like these, I guess it's not dictionary notation, it's more like we can use these squiggly brackets if we're going to just have things that don't point to values, in which case that becomes a set of things. But like just like as a general idea, like the idea of sets comes from dictionaries. And they're like under everything, they're like basically kind of related. The way that I don't know, the way that like, I think like distant cousins, I don't know, I think they're closer than like, for example, floats and integers, but something similar like that.
If we take grocery list and we just delete all the values in it and then we print type of grocery list, will it be a set?
So the thing is that you can't delete a value without also deleting the key.
But I thought you said that a set is
Oh,
a
right, so
dictionary with only keys.
Yeah, but it's when you write it explicitly.
Oh.
So if you do this, so okay, so I guess like the first thing would be, for example, our grocery list, if we wanted to delete all the things it pointed to, we could not. So we could leave them as like empty strings or something. But that wouldn't mean deleting it. Or we could even put like, I think none to them. So for example, if I want to print grocery list, it'll point to none, where none is like nothing. But I think, yeah, it would still be pointing to something, which is the issue. Like it would still, does that make sense? Or if it doesn't.
So for a dictionary, we have to have values for the keys. And for a set, we set the keys. We can't just like delete values from dictionary to have a set.
Exactly. Yeah. Mm-hmm.
Thank you.
Yeah, sorry about that. I think I made it a bit confusing at the beginning. Are there any questions with this? Otherwise, I might still go over it one more time really quickly.
I have another question. I'm sorry I keep asking questions.
You're good. That's good.
Can we make a dictionary out of a set, but we can't make a set out of a dictionary?
Can you make a dictionary out of a set? Yes, you can. You can't just do like dict and then the set inside of that, actually.
But if we like assign values to the keys.
So let's find out. So L right now is this. If I do print dict L, let's see what happens. I think it might break, honestly. Yes. So it says cannot convert dictionary, update sequence, number 0 to a sequence. Okay, that's a lot. But I think the reason why it can't do that is because you don't have values to it. And you need to have values.
Yeah, no, I meant like if we add values to each key, will it then be a dictionary?
Oh, yeah, exactly. Mm-hmm.
But we can't do it the other way around. That's the thing. Like a dictionary to a set.
A dictionary to a set. Oh, I see what you mean. So if I had grocery list, I think the same thing will happen with the, like, it will only give you the keys. Or it might actually break.
I just meant in general that like, we can't take a dictionary and turn it into a set.
No.
Yeah, okay.
So if you do like set and then inside of that you put a dictionary, it will just give you the keys of it, the way that, and so it'll give you a set of the keys of grocery list. But it's not the whole dictionary. It's just the keys. The way that like list also did that. And the way that like sorted did it too.
Can one of the values in a set be a list?
Can one of the values in a set be a list?
Since it's mutable?
Yes, but they have to be unique lists, I think.
Right.
So let's make sure. This is Python brain level. Oh, no, it can't. So I think they all have to be either strings, integers, floats are fine. Strings and integers. Yeah, I don't think unhashable type list. Yeah, because, okay, so I guess like the way that I would think about it is dictionaries. What type of keys can you have for dictionaries? And that's the same thing for like a set. So you can't have like, yeah, I'm pretty sure. That's a good question. I don't think I'd ever thought about, okay, I think if they're all the same, no, I think that still's not gonna work. Yeah, no, that's just not a thing. Sorry, I don't think I'd ever thought about this. Yeah, you can put lists. Sets are usually just used for like numbers, strings, floats, really mostly those three things. Good question though. Any other questions? Cool. So let's go back to the slides. Now, gone over sets. Here are a couple more in-depth examples of sets. So here we're making a set of like a bunch of fruits with a couple of repeats. For example, apple. When we print it, a bunch of repeats. So we have apple and orange are repeated. And you'll see that when you print it again, you only have unique things. And so this is like, think like a better example of why they're unordered. As you can see here, like they're not like in any sort of alphabetical order or anything like that. Again, just like re-emphasizing the fact that I think it's Jupyter that is messing with that. Let me check the chat really quick. Are we going to go over the sample question? So I'm going to try at the very end. If there is no time, Edna will be going over them in the next review session. So she'll be hosting the next one. So yeah. Yeah, and then again, you can do something of like, you can check if something is in something the way that you would a list, which then gives you like a true or a false. Yeah, you can also set a string, for example, into a set, and then it will separate every single thing and just get rid of all the repeats. So for example, oh my goodness, abacadabra has like a bunch of repeats, and so here it gets rid of all of them. You can also subtract two sets. And so what that means is that, again, this is, I think, going a little bit too advanced, but might be just cool to think about. When you do A minus B, you're sort of trying to see which letters are in A but not in B. And then you can also have like an or in between them. So that's basically the union of them. And so that means that like we would get letters that are in A or in B, or both. And then we have an and, which means that's sort of the intersection. So letters that are both in A and B. So in this case, it would only be A and C. And then lastly, we have letters. This is way too complicated for you all, but I think it's just, if you guys are interested, something else to think about. This is basically letters in A or B, but not both. So basically like things that, if you had like two circles that were meeting with each other, like a Venn diagram, this basically is everything but the middle. which is a good way to think about. So again, I think this is not necessarily going to be on the test, but just like a general idea of like cool set stuff. Any questions?
I tried creating a dictionary with only two keys, A and B,
Mhm.
and just random values. And then when I did print set that dictionary, it didn't print out the keys in order.
Oh yeah, Jupyter. Honestly, Jupyter and Anaconda as a whole is kind of weird. I don't know why the 3 and the 6 got ordered, but then sometimes if they're like strings, it won't get ordered and it'll ignore it. It's kind of strange, but it's. Sorry. Yeah, it's just like weird, like
But
that.
it can happen.
Yeah, it can have. I think it's just like it randomly prints it out. So.
Okay. Thank you.
Are there any other questions? Cool. So we're gonna go on to functions versus methods. So this is something that we went over a little bit earlier today, or like I alluded to the fact that we were gonna go over this. So functions are basically, I think the way that I like to think about it is functions return something. So when you have a function, you expect it to give you something back, whereas methods change something. And sometimes methods are specific to a type as well. So here we have like an example with lists, and this was very related to the last problem that you all had on your quiz, which was pretty tricky. And so for example, here we have a list of 5, 4, 3. And so when I do sorted L, nothing happens, right? And then I print out L again, nothing happens. And so the reason why nothing happens, if you look at this lower part, is that sorted returns something to us. So sorted makes a copy of L, of basically like sorted grabs L and then sorts it and makes a new copy of it essentially. And so when I try saving it into X, you'll see that it prints what we expected. So it prints out 3, 4, 5 instead of 5, 4, 3. So sorted is said to be a function because it returns something to us and it doesn't change what we originally had. So L is still the same even when you run sorted. Yeah, other ways that this relates to you all is, for example, when you had like your bulls and cows homework, you all would call how many bulls and save that number into something. Save that number that like bulls, how many bulls would return. So it's the same idea. And now we have methods. So methods are, they basically change something. So whatever you call them on, they change that thing. So here we have L and we have 5, 4, 3. And so when we do L.sort, L actually changes. And yeah, are there any questions with what the difference between functions and methods are?
For functions, when you do sorted L and assign it to X, say if I wanted to reassign to L, would you say that L is changed or that's just like reassignment?
It would be reassignment, yeah.
Okay, so
Because like the underlying L has been overridden. It doesn't necessarily has changed. So the variable, like what L is assigned to has changed, but not because you changed the original L, more because you scratched the original value and you put a new value in place of it.
thank you.
Mm-hmm.
Can you briefly explain what you mean by a method belongs to a class?
Yeah. So basically a class, I don't think we've covered this too much, but a class is essentially like a type of thing. So for example, integers are its own class. strings are its own class. And so as you guys have probably already noticed, there are some methods that we can't run with integers the way that we would run them with strings, or with lists, or with sets, or with dictionaries. So for example, when we did grocery list earlier, grocery list dot keys, that is a method that that belongs to dictionaries, and we can only run dot keys on dictionaries. If we tried running dot keys on like a string or like an integer, it's just going to error out for us. So what it means is that a method is specific to a class, aka to like a specific type. So I think for the most part, like, methods can change things, or they can just give you back things relating to the class. I like to think about it as changes because it really shows the distinction between like a return and a method, where I think like most of the confusion happens. But if, for example, in the example of like keys, right, it doesn't necessarily change anything. It just gives us back something about the dictionary. So information basically about the dictionary.
Got it. Thank you.
Yeah, I just added the whole like changes something because it's usually where the confusion between the two happen. Any questions about functions and methods?
Yeah, I have a question. So we said that lists are immutable, right?
No. Lists are mutable.
They're mutable?
Yes, because you can do list.append, for example.
Okay.
Yeah, so lists are mutable. But in the case of when you're doing, yeah, so here we see that a list is mutable because the method is changing L. Whereas here, it's just making a new copy of it.
Right. So for a method in a list, does it really change it or just rearrange it with the same one? Does rearrange mean change?
Yeah, that's a good question. Yeah, it basically what that means. It just rearranges things. Yeah, so the same list that you made and you started with is the same. We're just moving things around. The same idea would go for if we did dot append. So that's another listed method. So if we did dot append, the list remains. We just added something to it. Whereas functions make something completely new. Or not, where functions like return like a completely new occurrence of that thing. Does that make sense? Let me know if it doesn't.
Yeah, it does.
Cool. Are there any other questions? Let me look at the chat really quick. Do methods only work on objects of mutable classes? Yes. Okay, so I think it depends, right? I think there are different types of methods. So I know I said that it changes something. I might edit it before posting it up because that might cause a bit of confusion. But basically, like, when we're comparing methods and functions, I think that's what I would think. But really, methods could also be like get methods. So they basically return something about a dictionary that is helpful. An example, let's see. So strings are, no, let me not go there. Yeah, no, basically it's just like, it works on all types of classes, but it's like what the limits of the methods are. If it's an immutable class, then the method won't change the thing itself. So for example, tuples are immutable, and like they're known to be one of the most secure things that Python, I mean, not the most secure thing, but it's a very secure thing in Python because they can't be changed. And so it doesn't mean that tuples don't have their own methods. It just means that none of them change the underlying tuple that you just made. They all are probably like get methods and stuff. I will look more into this though, because it's a really good question that might have a bit longer explanation about it. So yeah. Did that answer your question, Kevin? Cool. Let's see. Yeah, are there any other questions? Either you can feel free to shout it out or put it in the chat.
So why doesn't sorted L change the list?
Sorted L doesn't change the list because it makes it sorts it, but it sorts it differently than like dot sort does. So sorted returns to you a new list that is sorted, whereas dot sort changes the original one.
Okay, so wouldn't sorted L just be useless without the variable?
Yeah, exactly. I mean, it would be happening somewhere, but then you're not saving what it's giving back to you. So it's just getting lost in like the Python space. It's like Python space is not, I guess it is sort of, it's not a thing. It's just like a phrasing. Yeah, it just sort of gets lost there. Like you're not saving it into anything, so it's useless basically. Which is why sometimes like, I don't know if you guys have had this bug, but like you'll use sorted and then you'll be going, you'll like be going like, why is this not sorting when I'm telling it to sort? And that's because you're probably not saving it into a variable if you're using sorted.
What are some other examples of functions like sorted?
Yeah, so I can think more of Java examples, but let's see, what's another example of it? Of a function. Oh, I guess like the dot random would be another one. So when you do random dot random or any type of like random related thing, if you recall, you have to save it into a variable. So basically like dot random returns, remember, a number from 0 to 0.99999. And so if you just run like random dot random just out there, it won't run. Or like it won't do anything because you're not saving the value that it returns. Another example of it could be like math.py. So when you run math.py, like pi is not all of a sudden just going to exist somewhere. You have to save that into a variable. Yeah, I think those are a little bit different because they come from libraries, but it's the same idea of like they're returning this thing and you need to make sure that you're saving it into something. Are there any other questions? Someone said go faster. I'll try. Any questions? Cool. Okay, so we're gonna go on to the next one. So we're gonna go over NumPy. And so recall, NumPy is like a super helpful library. And so things about NumPy. So here's like couple of methods that are helpful for like making NumPy arrays. So you can do NP, right? So usually when we import it, we do import NumPy as NP. And so if we want to make a NumPy array, we just do np.array, assuming that we called it NP, right? If we just said import NumPy, then we would have to do numpy.array because we need to make sure that NumPy is like being grabbed from the library. Another way to make an array is we can do an array of ones. So if we do numpy.ones and then the length that we want our array to be, this would make basically just like an array of ones, which I think was part of like one of your homeworks a while back. If we do np.arange, so that's one thing that I really want to emphasize. For the longest time, I thought it was a range with like a missing R. It's not that. It just literally means like a range. So when we do numpy arange, what this does is that this makes a numpy array from 0 to whatever number you feed it. And so if we did if we did np dot arange 5, this would basically give us 0, 1, 2, 3, 4. And then lastly, we can do a dot size. Let's assume that a is what we're going to call our array. So what this gives us is this is going to give us the size of it, which just means the rows times the columns. If you're thinking about it like in a grid format, that's just how many little squares do we have in our grid. And then we have a dot shape, which gives us the rows and the columns. So this gives us like a tuple of rows, comma, columns. I'm missing a little dash here, but yeah, it's like not a function. You just do a dot shape. I will make sure to fix that before I upload it. Oh wait, sorry. Yeah, and then we also have reshape. So what reshape does is if you have a linear array, I didn't put this in there, but I will add it before I upload the slides. If we do a dot reshape and we give it, say we have 25 little squares in our linear array, that's just like a straight line. If I do a dot reshape and I do 5 by 5, this will reshape my array to be a 5 by 5. And then after that, here is how you access an individual value of an array. So if I want to grab the very first value, I would do 0, 0 in like my 5 by 5 array. I would do 0, 0, which is also equivalent to 0, comma 0 in like the same brackets. And what this gives me is just like the value at that specific row and at that specific column. A couple of things about NumPy. Let me just check what time it is. Okay, a couple of things about NumPy. The length is fixed, and we cannot grow and shrink the arrays without making a new copy of it. So basically, once I make my array, so you can basically think of it as like NumPy arrays are immutable, sort of thing. And yeah, what it means by I cannot dynamically grow or shrink arrays just means that I cannot just all of a sudden make it smaller or bigger the way that I would maybe make a list smaller or bigger by doing like dot append. And then the last thing is that basically everything has to be the same type, with the small exception of some NumPy is cool with you having a combination of integers and floats. But besides that, yeah, they just basically have to be like the same type. Like you can't just have an array of like a bunch of highs, which is, it's really rare for NumPy arrays to be used for strings. I don't think I've ever actually seen it. But yeah, they have to be the same type. Are there any questions with the NumPy arrays?
So can't you change like specific elements of an array like we did like for the lab for like humanities,
Oh,
for example?
Yeah, you can. So you can change specific.
So then is it still
so you're not, in that case, you're not changing the length, or like I think what we're saying by like they're fixed. So they're sort of immutable. They're not, I think immutable is not the right word because immutable means like it's super strict, you can't change anything. The immutable part of NumPy arrays is that you can't change the length. So your length is set. If you want to change what's inside of it, you can. That's a really good point. Glad you brought it up. But yeah, so you can change individual elements of NumPy arrays. Mm-hmm. Did that answer your question?
Yeah, thanks. Makes sense.
Yeah, glad you brought that up. That's a really good point. Could have missed that.
Can or can't?
Can or can't what? Sorry.
You said that we can change individual elements or can't?
You can.
Okay.
Yeah.
And also, when you do np dot array, is it like an empty array?
Yeah. So I guess like in this case, we usually do np dot array and then the length we want our array to be. And if we just put like, so for example, if I do np dot array and I put 5, that's going to make an array of zeros. But it's like the weird, I don't know if you guys have noticed, but it's like a weird type of 0 where it's like 0 point. So I can show you all really quick. Let me share my other screen. Okay, so I'm here. I'm gonna do
What would happen if you
Thank
put
you.
like a list of empty strings?
if I had a list of empty strings here.
Yeah.
I think it should still work, but NumPy is usually just for numbers. So let's find out and make sure. Yeah, so it would just be an array of empty lists. But like in theory, right, there's still like a value inside of the NumPy array, even if they're empty.
So for arrays, we have to use the same types of objects, but they're mutable in a sense that you can change the individual elements as well as the length of an array.
You can change the length of it. You can change the individual elements of it. So for example, if I have 1, 2, 3, 4, and then I want to do x at, let's change the first one, x at 0, and then let's say I want to equal this to 10. When I print that, you'll see that that has changed. So it's now 10, 2, 3, 4.
Okay.
But if I try to add to it, I can't just do that to an array. There are like ways to get around it, but they all involve making a new array.
So you can like directly change the length through like appending or deleting elements from it.
Yeah, or I think that in NumPy there's also a dot join function where you can join two arrays. But that involves like grabbing both of them and then making a new thing.
Mhm.
Yeah, so useful things for NumPy arrays, it's just np.array, and you feed it some list, and that becomes an array. You can also, oh, sorry.
Sorry, when you do like the array dot shape equals like 10, 10, for example, is that array still like considered an array? Or like when you change into a grid, does that, is that a different type, I guess, under NumPy?
Oh, I see. No, it's still an array. With the exception of like, if I try to do like 0, actually, does it break? Let's find out. Yeah, so I think with the exception of like, it is now a 2-dimensional NumPy array. So for the most part, they have the same methods, with the exception that like, if I try to do like a 0 by 0, but it's like a single line, it will yell at me about it. So I think mostly like reshaping it into a grid-like thing, or a 2D array instead of a 1D array, just sort of changes the way that you access it more than anything. It also, yeah, that's really the main thing that it changes.
Gotcha, thanks.
Let me check the chat really quick. What did you know, can you go over tuple is? Yes, I can. I'll go over it right after this. Actually, I'll go over it right after pandas. What did you say you had to change on the number slide, on the NumPy slide? Quite frankly, I don't even remember. Let's see. I just said I had to change like the little dashes. So I think this is a bit unclear. So we can just do a dot shape, or yeah, if you do a dot shape, that gives you the rows and the columns, but you don't necessarily call it as like a dot shape and then pass in the rows and pass in the columns. I just thought that was a bit confusing, so I'll fix that before I upload it.
So what do you do?
We just do a dot shape, but without this part. So here, let me show you all what I mean. So, sorry, I'm just moving from lecture to lecture. Okay, so let's say I have this, and then let's say I have a second row that looks exactly the same. Right, so when I do print x, this will give me Just kidding, it doesn't understand it, so I'm just gonna do this. And then from there, I'm gonna do x dot reshape, and I wanna reshape it to have 2 rows by 1, 2, 3, 4, by 4. And when I print x, nothing has happened because I have to save this into something. And then when I do z, you'll see that I have like basically a 2-dimensional array now. So once I have a 2-dimensional array, if I do z dot shape, this will return a tuple of the rows by the columns. So basically in the slides, I just meant it to be like this gives you this, but because I forgot to put a space, I don't know, it was 3 a.m. I was kind of sleepy probably when I was making them or something. I missed that part. So yeah, that's basically all that I just need to change. And I'll probably make little arrows to it so it can be a little bit more clear. But yeah, any other questions?
Wait, so if you wanted to make like X in like a 2-dimensional shape originally without having to do the reshape, how would you write that?
For the most part, you always start with a 1-dimensional array. Let me see if you can do shape. Might be able to do shape. Let me just make sure. Yeah, no, I think for the most part, you want to start with a 1-dimensional array, because np.array, let me make sure before I say it. Yeah, so oh, I lied. Okay, so you can do, I just didn't think about it when I was doing it. Let me go back to this. So you can do a 2-dimensional array if I were to do a list within a list. So let's say I want to do this and I want to do this. If I were to do this, let's sure. Yeah, so if I wanted to do this, this will actually give me a 2-dimensional array. So if I do a list within a list, that will shape that into that. I just honestly completely forgot, and it was just easier for me to do reshape right now. But yeah, good question. Let's see. Somebody asked if I can go a bit faster. So I'm gonna be here till 9, and for the most part, the things that I want to cover, I'm on a little bit ahead on. So I want to answer questions as best as I can. This recording, like this, will be recorded. So if you have to go, just go back and watch the recording. I'll edit it because it cut the thing in half. So I'll edit it and then I'll post it on either the files or YouTube, whichever one is faster.
So just last question. We wrote reshape, right? The first time we were doing it. What's the difference between reshape and shape? Or is there no difference?
So shape gives you what the shape of the array is. So it'll just give you the row, comma. It will give you the shape of it in a tuple. So if we do shape here, it'll just tell us like a 2x4. Whereas if I do reshape, what reshape does is reshape takes in an array that is 1-dimensional and it reshapes it to whatever you want. So let's say, I'm actually gonna make another one of this so I can show both. So let's say I have y like this, and then I delete this, right? So this is a 1-dimensional array, but let's say I don't want a 1-dimensional array and I actually want y.reshape, I want a 2x4. What that does is it changes that 1-dimensional array into a 2-dimensional array by the rows and columns that I gave it. So this will have 2 rows and 2 columns. A note about reshape is that reshape breaks if it's not the exact size of your list, or of your NumPy array. So if I try to do y.reshape by 2 and 5, that will break and it'll tell me that it can't do that because Like you can't just make 8 things into a 2x5. So it's just like a thing to note. Are there any other questions? Let me just check the chat really quick. Cool. So I'm going to go over tuples really fast, which is something I didn't include in the slides. But tuples are basically just pairs of things. And so tuples are immutable, so they cannot be changed. And another important thing about tuples is that they're like, okay, so they're subscriptable, which just means you can index them. The way that you make a tuple would just be x is equal to the little brackets. Let's just do hello and hi. And when I print that, it will just literally give me that exact same thing. Wait, sorry. I purposely broke this other part. Okay. Yeah, so when I print, that will just give me hello and hi. When I check the type, you'll see that this is a tuple. And if I just decide to do x at 0, and let's get rid of the type for now. That will just give me hello, because it grabs the first element of it. What other cool things about tuples? If I try to do x dot append something, it will absolutely yell at me because tuples are immutable. Also because append is not a method that belongs to tuples. If I try to get the length of a tuple, that does work as well. What other thing? If I try to make this a bit longer, and then I print out x, this will work because essentially tuples can be whatever. Usually tuples tend to be length of 2, but they can be any length. If I try to make a duplicate inside of a tuple, that will also work. So unlike sets, tuples are cool with having duplicates. But yeah, basically I cannot change a tuple unless I change the main thing. So yeah, those are the tuple basics. If you guys notice, Professor Cannon really likes you all to return tuples. And the reason for that is because they are immutable. And so if someone wants to hack your code, it's a lot harder for them to do that.
So Eliana, sorry, why are these useful again? Why do we have these? Because I'm just wondering, why would we, it looks like a list that's less helpful.
Yeah, so they're helpful because let's say I have a function. So my function is going to be called top secret. And I'm going to return a top secret message. Yeah, so we're going to say we are cool. And that's going to be our top secret message. And so if I return it as a list, right, and I'm going to have another function called hacker, and I'm going to be the hacker. And the hacker takes in a message, right? And so that message is going to come from, just kidding, it's not going to take in everything. It's not going to take in anything. And that message is going to come from top secret, yeah? So if I grab message and I do dot append, we are cool, and then I'm going to do dot append not. When I print message, this is going to give me we are cool not, right? Let me run the hacker function. So for example, if I run our hacker function, this is gonna print out "we are cool, not." So this is not my original top secret message, right? This is a message that has been tampered with. And so now if I make this a tuple, right? There is no way for me to change this. Of course, you might ask, wait, but like in that case, you can just make a copy of it and just make a whole new thing. Yes, you are correct. There are ways to get around this. But at the end of the day, the original message is still, it's like you're going to make a new copy of it and you're going to overwrite it or whatever. But the original message, like you have to like make a new message to be able to change it. Whereas like for a list, you literally just append to it. And like now your top secret message is like completely different. So it's like a very small example of it, but when you're thinking of like larger like software solutions that are like meant to be safe, this idea of like something like basically like if I'm going to show you something, like if I'm going to display something to the user or have some interaction with the user, I want to use tuples with it because they're a lot more secure than list. Like anyone that has taken a Python class, for example, for some websites can go on there and change the values of like things that are being returned. So for our purposes, like I'm still getting a little bit too advanced, but the idea is tuples are super great because they're immutable.
Liana, can you do list of message, like turn message into a list and then do message.append not?
Yeah, so if I do list top secret, that will work. Which is, but again, when I do list, it's making a new copy of it. It's not our message that we sent. I mean, even though like you got around it anyways, our message that we sent is still the same thing. It's just I made a copy that is now a list and I messed with it.
So for a list, you can change like both the elements and its length. And then for array, you can't change the element, but you can change the length. And then for tuples, you can't change element or change length.
Exactly. Yeah. Yeah. So tuples are like the immutable of the immutable. That you can't change anything. Like the way that you make it is the way that it is going to be. So if you guys notice, like, I guess like hint, for your homework project 3, when you are, or no, this wasn't for project 3. This was for, I guess not everyone's in finance, but if you were in finance, you probably noticed that like it asked you for a tuple of, I believe like the plate and something else. And so you had to feed in a variable 1 and then a variable 2. So like tuples can change because if you put like a variable in place of it, it will put whatever the variable is. So it doesn't mean that like tuples are always going to be the same exact thing every time. It just means that once I make it, this is no longer going to change. Even if I change my variable 1, even if I change my variable 2, once you make it, it's set in stone, making them a bit more secure. So like our hacker example is kind of lame, but like it's just for the idea of like, you know, it's whatever top secret returns, the original top secret message cannot be changed unless you like overwrite it or like use what it grabbed and like make something new. But like the original message does not change.
Got it. Thank you.
Mm-hmm. Are there any questions? Cool. So now we're gonna go over, well, we're gonna keep going. I will try to put like a little tuple slide in there as well. So if we go on to pandas, so pandas is another really helpful, super cool library. Recall, we use these for all our CSV files. So for finance, this was like your parking project. For humanities, this was the recent one you had, which I believe was the tweets. It actually was not the tweets. There was another one that you guys used a CSV file. But basically, what I'm trying to say is that pandas are helpful for CSV files. And the idea of it is basically they are like tables. And so here, for example, we see that I am making a series. So something super important to remember is the difference between a series and a data frame. So all a series is a table with only one column. So that is what a series is. A data frame, on the other hand, is a table. I'm saying table, but like you want to think more of like, I'm saying table because like when you think of like a CSV file or like an Excel file, right? It looks like a table, but it's just like for the purpose. It's like not exactly the correct wording. It's just so you all can connect. But basically, like a data frame, right, would be a table of several columns and several rows, or several columns, basically. So again, a series has a single column. It's basically only like a little rectangle, whereas a data frame is a lot larger. So one could say that you can convert a data frame into a series by accessing a single column, for example. So yeah, a lot of the homeworks that you all had with like pandas were hard because all of a sudden things are changing up and now it's a series, but then it was a data frame and all that stuff. So that's just an important distinction to remember. Here are like a couple of methods that I think are important. So in here, I'm making a series and my series is just 20, 21, 12. And then my indexes are just going to be London, New York, Helsinki. And so basically the series is just like the rows are different cities and the columns are just random numbers that I made up. Or just kidding, typical summer temperatures for each city. I'm pretty sure I stole this from the internet, I'm not gonna lie. So yeah, that's basically what that is. Again, if we do PD, which just means pandas, dot read CSV, we can read a whole full CSV file and pandas will convert that into a data frame for us, which is what you all did with a couple of the homeworks. I believe like project 3 was also like this. I can't remember what project 3 was, but I think it also used pandas. And the cool thing about pandas is that unlike, for example, like a dictionary, if we wanted to change the values and multiply all the values that a dictionary had by 2, we would have to grab the key, go in, multiply that by 2, and then go to the other key, go in, multiply that by 2, which is just straight up annoying. So the cool thing about pandas is that it has a lot of helpful methods that we can use. So down here we have our function called square. And so what square does... Sorry? Oh, I think it might be a mute error. Did you say something? Never mind, we're cool. Okay, so basically what you can do is you can apply some sort of like function and then we can just do the data frame dot apply and it applies that to everything, every value inside of our series. There are also other common helpful functions. So for example, dot head gives us the first 10 things at the top. I believe the default is 10, but if you pass in a number, it gives you that number. So if I passed in 100, it would give me the first 100 results of my data frame. If I did dot tail, same thing, it would give me, I think, by default, the last 10. I don't remember if it's 10, 3, or 5, but it's like a specific number. And yeah, tail would give me the opposite of that. iloc is used to basically locate specific columns of the data frame. Lock is used for that, and then iloc is just stands for like index location. So it does a similar thing, but by like index. So yeah, overall, pandas are super helpful. It makes working with large data files a lot easier, and it is widely used for like machine learning. So I am taking like or not machine learning, like data science. So I'm taking like a data science class, and literally the whole class is like pandas and NumPy. And both of these libraries are like super, super widely used. So can I repeat the difference between, between lock and iloc? Yes. Okay, so here we are. I'm gonna comment out everything else that we've been over. I should be putting a new cell, but it's just easier for me to copy on here. So I stole this from the internet. It's just like a quick data frame about like different snakes apparently. So it basically is the different snakes that we're looking at is like a cobra, a viper, and a site. I'm from Texas. I'm actually going to change this to rattlesnake because we have a bunch of them. I don't even know if I can spell it right. Okay, so it's a cobra, viper, and a rattlesnake, and it basically says like the max speed and the shield, whatever that means. And so for this one, if I did print df.lock viper, what do you all think this would give me? Any guesses? Guesses.
The row of viper.
So let's find out, yeah? Oh, I didn't import pandas. Yes, so you are correct. So it will basically give you what the max speed is and then what the shield is. So then I can do type of this. What type do you all think this will be?
Series.
Yes, a series. So if I check the type, you'll see that I have PandaScore series. That. So basically, like this is me locating a single thing. But now I could also locate several things. So if I put this in brackets and I do viper, comma, cobra, where do you all think this will give me? Oops, I'm missing one bracket. Any guesses?
A data frame with 2 rows.
Exactly, yeah. So this will give me a data frame because now I'm now searching for more than one thing. And so if I print this out, this will basically give me like a smaller thing of like my bigger data frame. And so that is what like the lock would be in this case. Now let me try to think if there's anything. Okay, so what do you all think will happen if I get rid of the brackets? Any guesses?
Would it be a list?
What do you think will be a list of?
Maybe
Yes.
the values?
Sure, let's try it out. So
Okay, I guess not.
yeah,
I'll give
so
you anything.
this will basically error out because lock, when it's taking in something, it either takes in like a single thing that it's looking for, or it's going to take in a list of things. Is one way to put it. Like I think if you look at the official definition, it just says like it takes in a label. In this case, it's more than one label, so that will break. Whereas if we put 2 brackets, then it's still considered a single label, but like that label has several things in there.
What do you mean by it takes a list?
So for example, the previous example was this. And so this doesn't break
okay.
because I have like a list of all the labels that I wanted to consider. So yeah, this is the example of like lock. So now let's go over iLock. So the thing with iLock is, I guess like the difference would be that this uses like the indexing of a data frame. So it's like concerned about positions. So for example, if I want to iLock something at location 0,
Cobra.
yeah, it would just be Cobra. So I think this is helpful when you want to only see like one half of your data frame. So I could do like from 0 to, I mean, I only have 3 values. So if I did from 0 to 3, this should give me up to 2, right? So it should give me the first 2 values. Oh, just kidding. I should do 0 to 2. There we go. Because this is 0, 1, and this is 2. And so if I do 0 to 2, that should give me only the first 2 values. If I do 0 to 3, this should give me all 3 values. If I do 0 to nothing, it will give me everything. If I do 2 to 3, what do you all think this will give me?
Only the
Just 2.
So this one will give me actually the last one, because it starts, so this is 0, 1, 2. So just, yeah, so just index 2. And so basically this one relies on the index, whereas log relies on like the labels that you have.
Will still work if we reindex the whole data frame by like labels or strings?
Yes. So I guess like whenever you, let me do a quick example. So whenever you print df, you'll notice that your data frame will print out like Cobra, Viper, Rattlesnake. And so what index does is originally data frames are assigned numbers from 0 to whatever the length of your data frame is. If I were to get rid of this, you'll notice that now I have 0, 1, 2, and no specific index to what that value belongs. So by me setting this, I am basically saying, I want this, like, I don't want you to, I want to be able to index things from this. So now, if I try to do ilog at Cobra, what do you all think will happen? Do you guys think it will break? Do you guys think it will work? Do you guys?
I think it'll break.
It'll break.
Indeed. So it will break because ilog expects a number. So yeah, basically like when you want to think of like ilog, just think of like integer or like I like thinking of like index location. Another way you can think about it is like integer location because it requires you to feed an integer to it. Whereas location is a lot more flexible because you can use the labels for it.
So for ilog, it will always work no matter how you index the data frame. And when you are using integers to index the data frame, ilog and lock will basically be the same thing.
No, so lock will not work with integers.
Oh.
So when I try to do lock of 0, this will break because it says, it basically is expecting a label and you didn't give it a label, you just gave it a number. Whereas if I put Cobra, then that's a label, so it recognizes it. Also, let's say like I was too excited and I put double A, this will tell you like, oh, that doesn't exist. So it gives you a big error, but the idea is, let me try to see if the error says anything helpful. Yeah, it basically says like key error, which just means that like Cobra doesn't exist, and it couldn't find it. So it has to be like an actual label that exists.
Okay, not integers, right? Because
yeah.
For ilog.
I guess unless your indexes are integers, right? In that case, but again, like you're sort of going around it. So for example, if I did, actually, I think this might have to be a string. Well, let's try it out. So if I did 5, 3, 10, and I ran that and I try to do lock of, I think they have to be strings, but let's try it out just in case. Oh, just kidding, that works. Whoa. So yeah, so I guess like a way to get around it is if your indexes are numbers, then you technically can use lock, but you're like being sneaky about it. Like that's not, it's only working because this is a label of the data frame.
Okay.
When I mean label, it's just like a header or like, you know, when you make a table, you put like the names and the names. That's
right.
what it is.
So lock only works when you like actually index the data frame. If you don't index that, then you can only use ilog.
Exactly. Yeah. I see a question. So somebody, why doesn't print as the nicer looking data frame? So in order to get the nice looking data frame, you have to do df.head. And so mine, do you mean like with the, I don't think you all had, like you have to do df.head. If series, I think that the main thing is that like it prints out a series, and series print out a bit different than data frames.
Wait, but why is this printing a series not a data frame? Because we did pd.data frame.
Oh no, this is a data frame. What I have right now is a data frame, but if I were to do block, I'm gonna put this back to what it was, just so that it doesn't get confusing. So if I do df lock Cobra, this is gonna be a series, and so series print out because it's like a single column. It will usually print out as like the column names and then the values, and then it'll tell you what row are you looking, or like what label are you looking at, and what is the type of the values of it.
Wait, can you try putting like a second set of brackets around Cobra? Because I think maybe that's what I'm thinking of.
Yeah, but here you're printing a data frame now. You're not printing a series. So I guess it formats data frames a bit different than series. You know? So like if I check the type of this will tell me it's a data frame rather than a series. And the reason why it's a data frame is because of those double brackets.
Got it. Thank you.
Mm-hmm. But now I can also do df.lock, and then I can do at max speed. Oops, I did type. Yeah, so if you want to get like the columns only, you basically have to do like lock and then the specific column. So another super important thing, and I think this is a bit more important than parameters, which is the only reason why I'm going to this first, is list comprehensions. So just know what it means and like know what they're doing. And so basically here we have like a basic for loop, and we are going to convert this into a list comprehension. So this says basically I'm going to make a new list, and then I'm going to iterate through some old list, and I'm going to do if filter I, and if that is true, I'm going to append, I'm passing it in through like a different function, but after that return something, I'm going to add it to my new list. And so this is equivalent to saying new list, and then we put the list notation, and saying I'm going to append expression at I for I in old list if filter at I. So this is the same equivalent thing as this. And a way to think about it is for some item in an old list. So basically like the for loop part goes in the middle. The condition that you're considering goes to the right. So in this case, we would have our if condition. If some condition, we would do that. We would append to this list. So basically, we want to think about, we are adding it to this list. We are iterating through it. And this is a condition that we're running on. Oops. And this will spit out a new list for us. And so that's sort of the basic of like list comprehension. It can get very complicated, but the way that I would think about it is just like the thing that you're adding, the iteration part, and then the condition on whether you are adding it or not is the way that I would think about it. And then, yeah, are there any questions with this? So in this case, like I used just like some function called expression, but this could have also been like append I plus 2. So in that case, this could have been I plus 2 for I in old list if I is greater than 30. Could be like an example. Is everyone good with that? Any questions? Okay, I think for the most part, this is the last one. So for machine learning, these two I think are the most important ones. So you want to know what supervised learning is and what unsupervised learning is. So supervised learning is like when we have the data available of like what the correct answer should sort of look like. So we have something similar to compare it to. And then unsupervised learning is when we have no training data. And so this means that like the algorithm is figuring it out on its own as it is going. So an example of like an unsupervised learning would be like clustering. But yeah, these two things I think are the most important of that big thing. I don't think there will be a lot of it on the test, but I do think it's worth going over. I think most of the tests will probably be, I want to say like the things we went over at the beginning more than anything. So there will definitely be NumPy arrays. There will definitely be, I mean, I haven't seen it, but just from past years that I've TA'd, I can with some confidence say that there will be dictionaries, there will be NumPy arrays, pandas, sometimes yes, sometimes no. There will be sets, there will be probably string related things from last semester. There will probably be some like function passing around stuff and doing things to what you're passing around. So you want to make sure you remember the difference between like a function and a method, and also like print and return. So yeah, that is the end of it. We have less time for questions than I would want, but like there's only 10 of you all left, so I will stay as long as you all need for me to answer like your questions.
Line quiz 2.
This one.
Yeah, what does that return?
Okay, so for this one, A would be 4, B would be 5, then eggs would be 4. So it's basically gonna like fill it up until it sees like something that looks different. And then oi would be saved under this like dictionary. So basically the key would be oi, the value would be oi, which is not that helpful, but, and then for this one, the quiz. So basically what this, when it has 1 star, it saves all those values as a tuple. So if we look at the above quiz that we have a bunch of 1s, basically that would save all those 1s as a tuple of 1s. Now, when we look at this one, KW, so basically keyword, X requires you to give it a keyword. And what we mean by a keyword is this little chunk. And so if I say oi is equal to oi, this is basically saying oi is pointing to oi. And then quiz is pointing to oo. And this is all going to be put into a dictionary that is saved under here, under KWX, under keyword X, basically. The KW stands for keyword. So these are variable length parameters, and what that means is that these can be as long as you possibly want. So in here, we could have put like 10 more other random things with keywords, and all those would be added to this dictionary. And we know that it is a dictionary because it has 2 asterisks. And for this one, we know it is a tuple because it has 1 asterisk. And so, yeah, these types of parameters are called variable length parameters, and they can be like as long as you want. And then within that, there are 2 types of variable length parameters. The first is positional, and the second is keyword variable length parameters. Does that make sense?
Yeah, absolutely.